Welcome, everyone, to the Cup of Coffee podcast with me, your host, Tom Dillon. This has been recorded live at our Tin Pot mobile studio and broadcast around the world. Today's topic is heat pumps versus gas boilers with a guest, unbelievably, the lovely Russell Selby. Before we start, I'd like to say by way of a disclaimer that today is a wonderful discussion, but nothing said here constitutes financial advice. And you should always take professional advice before investing your hard-earned cash. There may be the odd unplanned swear word along the way as well. The format for today is that it's a conversation, a bit of an interview with me and Russell, and that's it. uh, I didn't sell that very well, did I? I'm going to work on that. With regards, Mr. Russell or Mr. Selby, Russell Selby is based in South Manchester and was recently employed for 6 years as a sustainability consultant. Try saying that fast 3 times. He's now gone solo, and his goal is to provide a targeted approach to energy saving to get the best bang for the buck for his clients. I met Russell quite a few years ago and really enjoyed his company. And then recently we reconnected because he posted on the Cup of Coffee networking WhatsApp group, which, by the way, if you're not a member of, you should be. I don't know, Google it or something, and you can get on there or attend one of our meetings. Be invited to join, and he posted on there an article, if that's the right word, a blog post, whatever you want to call it, talking about heat pumps versus gas boilers, pros and cons. And I thought it was A, excellently written, and B, interesting, and C, quite topical. I thought that's something that's popping up more and more in conversation with the whole green agenda and bits and pieces. And so I thought I would get him, and increasing energy prices, of course, another factor in more people being keen on potentially on heat pumps. So I thought I would get him on, and I'm delighted to say he joins us today. Hello, Russell. How are you?
Good morning, Tom. Yeah, I'm really good. Thanks for having me on your podcast. Hopefully, I can share a few insights with the property folks and
I hope
something
so.
useful.
Yeah, I really appreciate you coming on. It's just a topic I'm a bit of a green bean. I don't think that's a massive secret. As long as you don't look at my carbon footprint, I can pretend I'm a green bean. So I'm no surprise. I'm fascinated by this topic, and I think a lot of people are. Let's get straight into it. I called a
Yeah,
heat pump company recently and said, "Hey, I've got a property that's never had a gas boiler, but the old, well, yeah, it's got a central heating system, but not a gas boiler. It's like a very old-fashioned system. It's packed up after 50 years, of course it has. So we've kind of got a blank slate here. This seems like a property that would be suitable for a heat pump type setup. And they said, well, the minimum price is 12 grand, and then it goes up from there. Which point I hung up. So, because as you put in your article, which by the way, will link with Russell's permission. We'll be linking with this podcast, so check that out. And Russell's contact details at the end, of course, as usual. But I thought, as you put in the article, maybe a boiler system, a traditional gas central heating system might be, depending on the options, somewhere between 2 and 5 grand, somewhere there. And then I'm being told 12 grand on the phone. So just so I can stop listening to this podcast straight away and go for a biscuit, if I'm one of the listeners or not, you have to persuade me to stick around. Why on earth are we
yeah.
talking about this? This is a horrible waste of money, isn't it?
Yeah, I mean, there definitely is a lot to be discussed around this topic of value and cost.
Mm,
And I think probably from the installer, it's probably a bit short-sighted of him to say that immediately and scare you away. I
sure.
mean, obviously not a very good salesman. But the topic is obviously covered in the post,
Mm,
and it is for most people the main, it's the main consideration. It's right
sure.
up there,
Yeah.
hopefully along with how sustainable and how much energy it saves.
Sure.
But at this point in time, the only thing which makes it competitive regarding price is
Yeah.
using the boiler upgrade scheme, and that can give you up to 7,500 back
Mm,
on the installation of the heat pump.
okay.
I would also say it's
Who's giving me
very
the 7.5
important.
grand?
Yeah, 7,500. You can get with the boiler upgrade scheme. You can get 7,500 pound grant, which will
Okay.
bring that 12,500 down to 5,000. And that is honestly the only way it is competitive with a boiler system.
Sure.
At least at the out the costs at the start. If
Yeah.
you then start to consider the potential savings over the next let's say 15 years of the boiler, then you're
Sure.
getting in a position where you're being comparable, and hopefully, if the system's designed well, you're then making significant savings.
Okay, so it seems like maybe I'd have been better off calling you because maybe I'd have stayed on the line a bit longer. All right, so I'm at least I've not hung up yet, but I'm still not convinced. So
Yeah,
talk to me about these savings over because essentially what you're saying is there's a grant which I imagine comes from the government, which
yeah,
that's usually where grants come from, and then you're also saying hey the running costs are lower and over a 10, 15 year period maybe I get my money back, maybe I end up ahead. Could you
yeah.
talk to me in of course broad terms? It'll depend on the property. In broad terms about those numbers as they sit at the time of recording, which for anyone who doesn't know when that was, we are just around Christmas time, 2024. Shoot.
Yeah, so it is a very complicated topic, as you can imagine.
Mm,
And the kind of pivotal part about a heat pump system is how efficiently it's set up. So
yeah,
if you imagine the cost of 1 kilowatt of gas is, I
yeah,
think, about 10 pence,
mm,
whereas the cost of the 1 kilowatt of electricity is 30 pence. So if you're setting up a system that isn't really, really efficient, it has to be at least a ratio of 3 to 1 to therefore be back at the original, cost of gas.
just to be really clear,
Then,
then, just to be really clear, the reason that that's an important thing because this lost me until I worked this out. Like I think this is really obvious to
mm,
you, but maybe less obvious to
yeah,
some listeners. Is that gas boilers? Guess what? They use gas, so that's a cheaper fuel. Whereas
yeah,
all heats, you can't get gas fired air pumps, heat
no,
pumps, can you? So they're all electric. So the stuff we're talking about is unfortunately on the dearer of the two fuels. There's good
yeah,
news coming, I feel sure, but just to start off with the bad news is we're using the dearer of the two fuels for heat pumps, whereas gas is of course gas and therefore cheaper on a
yeah.
traditional boiler system. Okay, sorry, carry on.
Yeah, no, it's just really important to be clear about it because it basically sets the benchmark for how the rest of the financial discussion goes.
Yeah, yeah, yeah,
So when you set up a heat pump, the reason why a heat pump's so efficient, and you're looking at getting if a heat pump is installed very, very well, you're looking at like a 5 to 1. So it's a coefficient of performance of up to 5. So every 1 kilowatt you in effect pay for, you get
yeah.
4 kilowatts for free extra.
Oh
The
wow.
the thing with a heat pump is it doesn't generate energy. Like a boiler, you're converting chemical energy to heat energy. A
Yeah.
heat pump, all it does is moves energy. So it
Mm,
takes energy from the air outside your house, even
yeah.
though it might be very, very cold, there's still energy in that air and it
Yeah.
moves it inside your house. And that's why it can be so much more efficient because
Yeah.
it's not a 1 to 1 efficiency of a gas boiler.
Yeah.
It's taking less energy it needs to move the air than the air and the heat energy it provides to your home.
Yeah,
So
interesting. I think one idea I had that helped me to understand this a little bit in sort of simple terms, like a story, would be if you said to two people in an identical space, you set up an identical
yeah,
space and you kind of compare it and you say, hey, I want you to make me say a bag of rice, and then one person goes right. I'm going to make some rice. So I've got to grow some rice. They put on all the effort to grow the rice, and then they harvest the rice. There they go. There's a bag of rice. Meanwhile, the person in the second room goes, has a look around and spots a fella walking up the street with a bag of rice. Goes outside, nicks it off him, brings it back inside. There's me rice. That's the heat pump. It's much more efficient
exactly.
to go and nick the rice than it is to grow
Go
or
go and
create
make
grown rice.
go and get the rice from elsewhere that's already been made and just bring it to your plate
And that's
basically.
what the heat pump's doing, isn't it? It took me a while to get my head around this. The heat pump is simply taking the heat, albeit it doesn't feel very warm outside often.
Yeah,
It's grabbing what little heat there is, bringing it inside, and going, "There you go, enjoy that."
yeah,
Meanwhile, a gas boiler is saying is growing the rice. Is saying, "Hey, we're gonna have to burn some stuff, like a
yeah,
whole new process to create some
yeah.
new heat, if you like." And that's a much less efficient process. Have I got that broadly right?
That's exactly correct. And this is the game changer is that getting this ratio
Mm,
as good as beneficial as you can is a key. Because
yeah,
if you're already clawing back from the fact that electricity is 3 times more expensive than
yeah,
gas, then you have to make sure that your system is set up in a way that you're, as a bare minimum, and I mean like is going to be 3 to 1,
Yeah.
as a roughly speaking.
Yeah.
Whereas actually, if you have a really good installer, um, and your system is set up in a particular way that makes it more efficient, then hopefully you can push for, up to 5 to 1 ratio. They call it a coefficient of performance of 5.
I think
And that
coefficient of
and that
performance is
is
a good thing to talk about because it makes us sound intelligent at dinner parties. So that's the bit I'm. If anyone tries to remember anything from this podcast, I'd suggest going with coefficient of performance and
yeah.
start
The
dropping that into
seasonal, the
daily
seasonal
conversation.
coefficients of performance. That's what you should be asking. Yeah. As a bare
Yeah.
minimum, especially if you have an installer come to your house, and this
Mm,
is something that I haven't dealt with a heap of installers, but I've dealt with a couple. For one, I know because of the grant is available, and unsurprisingly, I think heat pump installers may be slightly pushing up their installation costs a little bit. I
mm.
hope none of them hear me now, but
Yeah.
I suspect that would be the case.
Sure.
But also, they're not all created equal. Like,
Mm.
a good installer is not the same as an installer. And if you can ask the right questions, then hopefully they'll be able to um really optimize your system.
Okay.
One other thing that I think that's really important is that it's hard for me to tell someone to go and plonk a heat pump in their development or their already, I guess, lovely home or whatever. And it's much easier for me to say, hey, if you've got a development that's being refurbished, then this would be the time to put it in because it's at this moment you have the ability to optimize the system.
Mm.
Whereas if you're just sticking it in as a replacement as a boiler, then it might, I mean, it's 100% going to reduce your carbon footprint. So if that's your only goal, then great. But if you're considerate, like most people, of the financial benefits, then I would really direct most my aims now to people who have a project that maybe if they're back to brick, then you
Yeah.
can really make significant savings with a well-designed heat pump system, especially if you anticipate that, let's just say HMO is going to be, you know, 15 years, you know, generating hopefully a profit for you, then
Okay.
that's the difference.
No, fair enough. The good news is a lot of our listeners are property people, property investors. Welcome everyone, and also welcome any homeowners who've stumbled in from the cold, looking for a heat pump to warm them up. Um, so in short, to summarise your point there, it's the final point you made was this seems to work better currently and probably in the future too for systems where you can spend more time on the design. It's maybe more
Yeah,
difficult where it's like, oh, the boiler's packed up. I know, let's fit a heat pump. It's maybe a little bit more involved than that, or it's going to potentially cause a little bit more disruption and or be more difficult to
exactly.
design properly. Is that roughly it?
Yeah, that's it. I don't want to discourage people who want to switch to a heat pump. Like, obviously, I encourage that, and I think if you have a good installer, they should be able to really tell you what you're going to get for your money. But what I am saying is that if you really want to optimize your heat pump, then it's best to do it at a back to brick stage, or when you're in the process of refurbing a property. Yeah.
Understood. Understood. Speaking of the cost of energy, I'm now um, taking something that I found in your post article. I'm not sure what to call it. Let's call it a post that I found in there that thought was very interesting. So we said, hey, one of the downsides of this is currently the energy is roughly 3 times the price of gas, give or take. Well, what you said in the post that maybe because of the way the energy mix and the move towards renewable, the chances are that will change and that gap will close. Is that right?
Yeah, so I've actually got a post on the blog, kind of about what Labour have done since they've come in and some of
Yeah.
the things that have been said. But really, if the UK is committed to their climate targets, now obviously we are legally bound to these targets. So I have to take the stand that the government is going to do these things. Whether or not they do, I don't know, but legally they are going to do these things.
Yeah.
So I think over the next, 5 years, certainly, and going onwards, we'll see, more infrastructure for renewable energies, which will therefore reduce the cost of electricity and less, dare I say, maybe less subsidies for oil and gas,
Yeah.
which will then see that price difference, the price gap smaller and hopefully come down to a point when, the cost of electricity is comparable.
No, fair
And
enough. So, like, just as an
that just
example, then,
means
if
that means down the line, yeah, with that cumulative cost of energy. Okay, even if now, let's just say even if now your heat pump is the same as a boiler,
Hmm.
then in 5 years, it's going to be making savings.
No, sure. So if for example, gas got a little bit more expensive in the future and electricity got a little bit cheaper, and so suddenly the ratio there goes from roughly 3 to 1 to roughly 2 to 1,
Yeah,
then suddenly you've got I think I've got this right, coefficient of performance of 4 or 5, whatever it was. Suddenly
yeah,
you can see that you may be paying your running costs to maybe half what they would be for a gas boiler, and therefore you're going to get
exactly.
that your return on investment is going to be quicker for the heat pump. Is that right?
Yeah, that's exactly it. I mean, and a lot of the topics of sustainability that I deal with, as you kind of alluded, right here and now, the difference isn't so noticeable.
Yeah.
But given the trends that we're going to see over the next 10 years, that let's just say you have a buy to let or a HMO and you're not making, if you're not anticipating let's say the more stringent rules around, you know, let's say part L, which is, the heating demand in your home and insulation, then you're going to have to reinvest. And I think aside from all these different topics, everybody knows that if you're having to do things twice, this is not this is the worst thing for anybody, having to do things twice. So it's almost like one eye on now and what is the cost of now, but also one eye on the future and the cumulative savings, or the accumulative, yeah, I guess savings from future bills, basically.
Okay, fair enough. So, does I'm now going to do the questions that some because I know some people listening will be like, yeah, ask this question, so I'm going to ask it.
Yeah,
I
this
think
is
I know the
good because
answers,
I
but I'm
need
going
to
to
be
ask it.
asked.
I,
I
I,
need to know.
yeah, I mostly know the answer to these, not because I'm smart, but because I read your post this morning, or reread it. So I've heard they're noisy, these units. Are they noisy?
Um, Obviously, it depends what you consider noisy, but
Nah, that's
yeah,
pretty noisy. Is it like that?
no, it's considerably less. I
All right.
think the loudest heat pumps, obviously, it depends on the model and how much you're willing to pay for a nice, really quiet one, are
Mm,
similar to like a loud refrigerator hum. And in
okay.
most circumstances, this gets swallowed by just background noise around your house. And I would say if you live in a particularly nice place where it's completely deadly silent outside, then you've probably got enough space to position it in such a location that you don't have to hear it. I mean, you can't put a heat pump, for example, right underneath a window,
Mm,
because if you have that window open, it will might have a distracting noise for the person inside. And also, when you get a heat pump, you can't put it within 1 meter of your neighbor. So,
right.
for that reason, for the noise reason that your neighbor shouldn't have to hear anything, and they only say 1 meter, so that just shows really that 1 meter distance is quite small.
Sure. Yeah,
So
we have a herd of deer in our garden. I wouldn't like to startle a stag, so this doesn't sound too bad noise wise.
you'll be
Um,
fine. You'll be fine.
the deer won't mind. Space, they're massive. These things, aren't they? Don't they take up loads of room?
It's definitely I'd say a challenge in regards to the fact that everybody's threw away their hot water tanks maybe like
Mm.
10 years ago.
Yeah. And these
Now they're
systems need one
adding.
to be honest, don't they? Or sometimes they even need two. Is that right?
They definitely need one. A air to water heat pump needs
Yeah.
a tank,
Yeah.
and usually that tank will have a section on the top for hot water. So it'll be like a
Mm.
combined thing. They'll be
Ah, okay.
separate, but in one space.
Gotcha.
And one of the tanks is used for the direct hot water
Mm.
for your showers and sinks and whatnot. And the other tank is your heating loop.
Yeah.
Um, and yeah, you'll just need a normal hot water space depending on the size of your house or project. But the other thing that has to be considered is that obviously you have an outdoor heat pump with its compressor, which is outside, and you have an internal one, which is in effect a decompressor. The decompressor is generally quite small and can fit in, let's just say, one kitchen cupboard unit. What are they, like 600 deep and maybe similar wide,
Yeah.
or even a little smaller? Whereas the outdoor compressor is a little bit bigger. But hopefully you have space in your amongst the day that your compressor can fit. But space can, unfortunately, space can be a breaker.
Yeah.
And it all depends on the installer and how ingenious he is with its location, because obviously it has to be located near a wall, similar to a boiler. So it does take into consideration, that's for sure.
No, sure. If you're in a small London flat or Tokyo flat, it might be difficult. Which I think people accept. The ones I've seen, just to give people an idea, the outside the compressors I've seen, and you can tell me if I've got this about right. It's about the same size as, say, a medium-sized deer. So about 1 meter by, I don't know, 1.5, and about 40, 50 centimeters wide. 40, 30, 40 centimeters wide. Is that roughly the right size that most of these units are, or does it vary?
Uh, I'd say they are, yeah, typically maybe like 800, maybe like a washing machine or something like that, or a
Okay.
smaller washing machine,
Right
something
on.
like this. That's what you're
More
having
than
outside your home, which, you know, aesthetically might not be what you're used to.
yeah.
But I think these behavioral trends are also another thing that has to be tackled. It's not just financial kind of trends, it's behavioral things. People aren't used to these things. And I think
Sure.
when they become more common,
Become less of a
maybe it'll be cool to have a heat pump. Who knows? You know,
well.
maybe it will.
Well, maybe it'll be cool, but maybe it'll also be, and this is another thing I wanted to ask about, is I go and spend 20 grand on it, 10 grand on a system or whatever it is. Do I get this back when I sell the house? What, has there any research been done on that? And what does it say?
Yeah, so I did a post also available on the website that kind of compares sustainability and valuation of houses, and like there's not a huge amount on it, but there is
Yeah,
a noticeable difference, and you do have a premium for more sustainable houses, i.e., a better SAP rating, you know, on the A to G. Um, but the research that I found is similar to the previous advice that I kind of said, is that I think the valuation and the appreciation, or should I say, a house that isn't well insulated and has a poor thermal performance and lacks some more mod cons, is going to appreciate or depreciate at a slower rate than a house that is well endowed with such things. I think
yeah,
given the climate, it's just going to be more pressure, and homeowners are going to know 5 years from now which houses are going to cost them a fortune to run and which houses are going to be, you know, better on their wallet. So right now, maybe there's a slight difference, but again, I think in 5 years, everyone will be acutely aware of these things. And if you've got the opportunity to do it now, I'd say go ahead. And then in 10 years, if you do sell or for whatever reason, it's going to be a more noticeable, well informed customers and market, I
I see.
think.
It's like buying Bitcoin early days, isn't it? When no one knew about it, it made no sense at all, and everyone called you lunatic. And then now you look like some sort of genius, 10 years on. By the way, none of this constitutes financial advice. Don't buy Bitcoin. Do buy Bitcoin, whatever you want, but don't come blaming
I have
me
a
when your
few
heat pump
Bitcoin,
breaks
but
down. Yeah, yeah, I always have a few Bitcoin, and then use it to buy a heat pump. None of this constitutes financial advice. Meanwhile, a few times, and uh, probably coming towards the end, you'll be delighted to know. Was uh, what's my question? Come on, question. You mentioned a few times the importance of, which I don't, it's true, the importance of finding a good installer or asking the right questions. And I think that's true with a more traditional gas boiler, but probably less so. I get the impression from the way you've said it and the amount of times you've sort of stressed it, it
yeah.
really does make a big difference with these systems. Why is that? And what questions should I be asking, given that I don't know what questions to ask? Mm.
Yeah, so I think it's crucial because it's relatively new.
Yeah.
So as it becomes more mainstream, the installer standard's going to improve as with anything, and they have to be more competitive. They have to be better. Whereas now, they're getting the ability to install it. They're doing their qualifications, and they're like, "Oh, people are buying it because there's grants. Throw it in." But basically, I'd say there's a lot of discussion around one of the things with heat pump and the efficiency of the heat pump is that it is best for moving a small amount of energy very, very steadily and
Mm.
continuously. So it
Mm.
can't deliver a large amount of energy quickly. And when it
Mm.
has to do that, that's when it becomes really efficient. So such things to keep that need to deliver large amounts are crucial. So, for example, if you want to apply for the boiler upgrade scheme, they suggest that you have an EPC rating of C or above
Yeah.
to for a heat pump to be kind of viable.
Mm.
Um, and the EPC rating scale is pretty questionable anyway. But I would go with the kind of ballpark that your heating demand should be no higher than 60 watts per meter squared at its maximum. So a installer should be calculating quite accurately what your heating demand is. You should be able to ask him or her, you know, can I see the calculations that you've done to show me what heating demand every room in my house has, what total heating demand my house has, and what my hot water demand is. And
Yeah.
then he should be designing the system. So this is like the radiators, for example, which in some cases they have to be changed because one of the primary most useful things that heat pump needs to keep its energy slow and steady is that you've probably heard this, they need quite large emitters. So the fact that you have a large surface area of heat giving off heat emitting into the room means that heat, that water in that, let's say, radiator, doesn't have to be as hot. And that helps to reduce the demand for the heat pump.
And therefore increases the
So
efficiency of it, right?
yeah, and reduce that. So your installer should be calculating every room, should be calculating the size of the heat pump, size of the radiators and emitters, and basically proving, and you should be able to anticipate the coefficient of performance, or should I say the seasonal coefficient of performance. And it's all about keeping that temperature difference between the air outside and the air and the water that's being delivered to the radiators.
Okay.
So, for example, if I was to do, I hopefully will be doing a project next year of my own, and I will be installing a heat pump, definitely. I will be putting, for example, underfloor heating throughout the house. Because underfloor heating has the largest surface area of any emitter. It has more surface area to dissipate that heat into your house. And that way, the temperature of the water in the underfloor heating can be considerably lower, as low as 40 degrees, 35, 40 degrees, compared to a traditional radiator, which is blasting 55 degree, maybe more, 60-degree heat through your radiator system. And that's why if you're able to do a heat pump installation in a stage where you're designing your HMO or buy to let or your own personal home, it's really good to start at an early process.
Yeah, fair
Um,
enough. That all makes sense. Now, I'm right thinking you're not an installer, right? So where do you
Correct.
fit in on this? From what I understand, that you, like this is in case anyone listening wants to get in touch with you and wants to, wants to use your services. We're trying to find out what the services are. I'm guessing that you help to work with people to come up with schemes or adapt schemes or improve schemes to get best bang for the buck, as it said in the intro, to
Yeah.
help to make sure those schemes are efficient and effective. Is that broadly it?
Yeah, so my ideal model, I should say, would be to come into a project at its early stages and
Yeah.
model its energy consumption, and then also inform the either direct to the builder or the client or whoever it may be, where
Hmm.
they can make alterations to their design and how much energy saving that will give them. So for example, if you increase insulation here, this could save you this much money. If you improve the air tightness and the quality of this window that are very, very bad, or then this could have this much savings. But all this modeling allows me to understand the heating demand of the house and therefore, in effect, I do very similar calculations to the heat pump installer. So in previous instances, I've provided the heat pump installer with my data and said, hey, look, we've got this much heating, we've got this much heat demand, this much wattage of heating demand, and we've got this type of build up, and they're able to provide, therefore, more accurate plans in effect and ideas. I also am quite good at kind of like pushing installers in the sense, because I kind of know what they're doing. I don't know the intricacies, but I know how they can optimize, and I can nudge them to be a bit more adventurous with their ideas. Um, but
Sounds good.
I also do other things in regarding sustainability. I've done biodiversity assessments for planning applications. I've also done kind of troubleshooting. So I've had people come to me with a HMO that's just leaking heat, and they've kind of gone, can you give me a few tips here because I'm hemorrhaging money in December and it's not a good time.
That makes
So I
sense.
do, I do quite a few things, yeah.
Excellent. I think that's really clear. If people want to get in touch with you, we'll put your contact details with the podcast, with this podcast, of course. But people are lazy, so how should people get in touch if they're listening and want to click on something?
Yeah, so you can email me directly at russell.selby.resolve@gmail.com, or you can visit my website, which is resolvesustainability.co.uk. And on there, I have a one-page website which explains kind of my services and how I can help you. And I also have the blog to the side, which is in effect basically my research, trying to understand the markets, trying to understand what's best for people, and putting it in a blog format for people to read for themselves. So next week, for example, I have a another heat pump discussion where I'm talking about the 9 areas to make your heat pump more efficient, and that will match nicely with this discussion. So people should definitely check that out next week.
Superb. So just in case anyone missed it, that's Resolve www. The people don't say that anymore, do they? Any more than they send post. But it is for those of us who are 44 and older. It's www.resolvesustainability.co.uk. Like to thank everyone who's attended, watched on YouTube, or listened to this on the podcast. A special thanks, of course, to our lovely guest, Mr. Russell Selby. Thank you, Russell.
Thank you very much, Tom.